So, have you ever, as a philosopher, and I'm sure you have, wondered about logic itself? Like, is it this rigid, unchanging thing, or is it something that can evolve, something a bit more fluid? Well, today we're going deep on a guy, Jan Łukasiewicz, who really pushed the boundaries of what logic could be.
Yeah, he's a fascinating figure. This deep dive is based on the Stanford Encyclopedia of Philosophy entry on him. Really comprehensive. It covers his life, and especially relevant for you, his really groundbreaking work in logic.
And what we're aiming for today is to understand Łukasiewicz's main ideas, especially that whole many-valued logic thing he developed. Why would a philosopher find that so interesting? What does it mean for the way we think about, philosophy itself? We'll also touch upon his work on the history of logic and his philosophical views in general.
Right, sounds good. So Łukasiewicz lived from 1878 to 1956. That's during some pretty major upheaval in Europe. He was born in Lowell, which at the time was part of the Austro-Hungarian Empire. Get this, he earned a doctorate sub auspiciis imperators.
Oh, what now?
It means basically he got his doctorate under the patronage of Emperor Franz Joseph himself. The emperor even gave him a diamond ring to mark the occasion. That's how brilliant he was from the start.
Wow, a diamond ring from the emperor. You don't get that for just showing up. And it wasn't just academia for him either, right? He was the minister of education in the new Polish government after World War I.
Exactly. But his philosophical roots run deep. He studied under Kazimierz Twardowski, a really important figure. Twardowski stressed rigor, really paying attention to detail, being clear in your thinking. It's all part of the tradition that started with Franz Brentano.
Very thorough, very precise. But Łukasiewicz didn't always stick to Twardowski's approach, right?
True. Early on, Twardowski, following Brentano, saw psychology as the basis of philosophy. But Łukasiewicz was drawn to the new logic of people like Russell and Frege, and he moved away from that psychological grounding. He wanted to reform logic itself, push it in directions that Twardowski probably wouldn't have.
Interesting. So a bit of a break there, but didn't they also work together on something?
Yeah. Despite their differences on the fundamentals, they both had huge respect for the history of philosophy. They even collaborated on a Polish translation of Hume's work. And it's worth pointing out, Łukasiewicz developed a super clear way of writing, maybe even clearer than Twardowski.
Well, we could all use a bit more clarity in philosophy.
Yeah.
Okay, so we've got a good sense of his background. What about his work before he really started shaking things up in logic?
So in those years leading up to the First World War, he was really into the methodology of science. His doctoral dissertation was all about the relationship between induction and deduction. At first, he thought of induction as aiming for probable general conclusions. But he shifted his view, kind of anticipating Karl Popper, and went for a hypothetico-deductive view.
And what does that mean?
Basically, he argued that science moves forward when you come up with general ideas, and then you deduce specific things from those ideas, and then you test those specific things against, what you observe in the world. If something you deduced turns out to be false, well, that means your initial general idea was wrong. He even talked about the creative elements in science, going beyond just the idea of scientists simply recording facts. So even early on, he was challenging the accepted ways of doing science.
Always questioning things. I like that. What else was he working on back then?
His habilitation thesis, the next step after the doctorate, was really interesting, especially from a philosophical point of view. It's called Analysis and Construction of the Concept of Cause. And it shows his Platonistic view of concepts. He thought of them as real abstract things existing independent of our minds.
Okay, I'm listening.
So he completely rejected any kind of psychological or subjective explanations of causality. Nope, he argued that cause and effect are connected by necessity. And get this, he equated that necessity with logical necessity. His motto for this work was Arceo Psychologiam. That's Latin for I banish psychology. It shows how far he'd moved from that Brentano school of thought. Nowadays, this work is seen as an early example of analytic philosophy.
So he's bringing the tools of logic to bear on these big philosophical questions.
Precisely. And that's not all. He also wrote about probability, and this work actually foreshadows some of his later ideas in non-classical logic.
Okay, I'm intrigued. Tell me more.
So in 1913, he published this monograph, Logical Foundations of Probability Theory, in German. And he was super innovative. He drew on Frege, Russell, and Bolzano and came up with a logical approach to probability using what he called indefinite propositions.
Indefinite propositions.
Think of a statement like X is F, but the X could be any member of a certain group. He said these propositions are true if they hold for all X, false if they hold for none, and neither true nor false if they hold for some, but not all.
Okay, I'm following.
And then he assigned these indefinite propositions a numerical truth value. Basically, the proportion of x for which the proposition is true.
So he's already thinking about propositions that aren't just true or false, and he's giving them values between 0 and 1, right?
Exactly. He even developed a whole calculus for these truth values. This allowed him to analyze complex propositions, conditional probabilities, and even derive Bayes' theorem. He saw this as a logical theory of probability, not based on objective chances or subjective beliefs.
That's pretty groundbreaking stuff.
Yeah. And two key ideas from this work really point towards his later many-valued logic. The idea that a proposition can be neither true nor false, and the idea of giving those propositions numerical truth values between 0 and 1.
So we can see the seeds of his challenge to classical logic being planted.
Right. Now, the work that really marks a turning point is his monograph on Aristotle's principle of contradiction. It's from 1910, and it's called, well, On the Principle of Contradiction in Aristotle.
So going right to the heart of classical logic.
Yeah. He dives deep into how Aristotle formulated this principle, looking at it in light of criticisms from Hegel and new developments in mathematical logic. He found 3 different versions in Aristotle's work: the ontological, the logical, and the psychological versions of the principle.
I'm guessing he had some issues with how Aristotle dealt with this.
You bet. He pointed out that Aristotle, on the one hand, said the principle couldn't be demonstrated, but then on the other hand, he gave this kind of indirect, pragmatic justification for it.
A bit of a contradiction there, maybe.
Maybe. Łukasiewicz argued that the principle of contradiction wasn't the absolute bedrock of logic, like some people thought. He suggested it was more of a practical guideline. What's interesting is that in the book's appendix, he gave a formal derivation of one version of the principle. And here's the catch. That derivation relied on the principle of bivalence, the very principle he later challenged.
Oh, the irony.
Right. He later admitted that this was a failed attempt at a non-Aristotelian logic because he was still stuck in that true or false framework. But the book did make waves. It sparked a debate with Stanisław Leszniewski, another logician, which actually helped Leszniewski develop his own important work. And the book also brought up this problem of future contingent events, things that might or might not happen in the future, and the whole question of whether they have a truth value now. And that line of thinking led him straight to his most famous work.
The many-valued logic. But before we get to that, tell me about his work in propositional logic. What did he do there?
He did a lot. Initially, he called it theory of deduction, following Whitehead and Russell. His 1921 article, Two-Valued Logic, was a big step. He brought together all the existing results in the algebra of logic, focusing on the 2 truth values, true and false. He saw them, like Frege, as what sentences actually refer to, but unlike Frege, he introduced 1 and 0 as actual symbols for truth and falsehood.
So incorporating them directly into the system.
Right. The thing is, this article was meant to be just the first part of a bigger work on 3-valued logic, but he never finished it.
Any idea why? Seems like a big project to just drop.
It seems like his ideas were developing so fast that the framework he started with just couldn't keep up. In that Two-Valued Logic article, he introduced the concept of axiomatic rejection alongside the usual axiomatic assertion. So not only could you assert axioms, you could also reject them.
That's interesting. So a more nuanced approach.
Definitely. He used 0 and 1 not only as truth values, but as symbols within asserted and rejected formulas. It's like a symbolic version of truth tables. Later on, he developed that parenthesis-free notation that we know as Polish notation, and he formulated some really fundamental principles of logic in this new streamlined system. And he also worked with Alfred Tarski, another logician, on a paper that explored both classical and his developing many-valued propositional logic.
He was really on a roll. And he even wrote a textbook on this, right?
He did. In 1929, he published Elements of Mathematical Logic based on his lectures. It's a really clear and concise presentation of classical propositional calculus. It follows Frege's approach, relying only on implication and negation as the basic connectives. And he managed to prove like 140 theorems in just a few pages, all in a really compressed notation.
That's impressive. It seems like he really had a knack for finding elegance in these logical systems. And it wasn't just him working on this, right?
Oh, no, not at all. Łukasiewicz and his students, really bright people like Tarski, Lindenbaum, Supecki, Sobociski, and Wasberg, they made studying propositional calculi a central part of their work.
It sounds like a real hotbed of logical research.
It was. They didn't just look at the full system of propositional logic, they also looked at smaller parts of it, like those based solely on implication or equivalence. They were especially interested in finding what they called perfect axiom systems.
What makes a system perfect?
It's about minimizing everything. The fewest axioms, the shortest possible formulas for those axioms, making sure no axiom can be derived from the others, and using as few basic logical connectives as possible.
A quest for ultimate logical simplicity, I can see how that would be appealing.
Definitely. Some people saw it as a kind of logical game, but it was more than that. It was a philosophical quest for, pure logical perfection, as Jan Wolski, another philosopher, put it. For a while, it was almost a joke that only Polish logicians could play at this level. Though, funnily enough, the American logician Emil Post, when Tarski congratulated him for his contributions as a non-Pole, pointed out that he actually had Polish heritage. And then there was Carew Meredith, an Irish mathematician, who got into the game and even outdid the Poles in finding short axioms.
It's amazing how these ideas attract people from all over, so it wasn't just about shorter axioms, right? What other interesting logical results came out of this work?
Well, Łukasiewicz used many-valued matrices to show that axioms in different logical systems, including those of Frege and Russell, were actually independent from each other. He also proved the completeness of the full classical propositional calculus and its smaller parts, like the implicational and equivalential fragments. He even showed that the equivalential calculus could be based on just one axiom and that you couldn't make it any shorter. Tarski did something similar for the pure implicational calculus, and then Łukasiewicz found an even simpler single axiom for it. This wasn't just playing around with symbols, it was about getting deep insights into how these logical systems worked.
Really exploring the foundations of logic itself. You mentioned variable propositional functors earlier. What are those exactly?
Right, so in your standard propositional calculus, you've got logical connectives like negation, implication, and so on. They have fixed meanings, defined by their truth tables. Variable propositional functors are different. They're like placeholders for connectives that take propositions as arguments, but their meaning isn't fixed in advance.
I see, so they're more flexible.
Yes. It's like having predicates in first-order logic, but instead of applying to objects, they apply to propositions. It makes the logic much more expressive. Ledniewski, the guy who debated with Łukasiewicz about the principle of contradiction, he developed a whole system called protothetic that used these variable functors and quantifiers over propositions.
And did Łukasiewicz work with these too?
He did, but in his own way. Ledniewski's method for dealing with them, especially when things got complex, involved all these auxiliary definitions that Łukasiewicz found a bit, clunky. Łukasiewicz's approach, which was kind of like Frege's notation, was much more elegant. He basically said any context with a single free propositional variable could stand in for a functor. And to show where the argument should go, he used an apostrophe. He called it substitution with apostrophe. This allowed him to express things really concisely.
So more efficiency, more elegance.
Exactly. Even the principle of bivalence could be expressed super succinctly using this method. And get this, Meredith, the guy who was finding those incredibly short axioms, showed that the entirety of classical propositional logic with variable functors could be derived from just one axiom. Even the bivalent propositional calculus with quantifiers and variable functors could be derived from a single axiomatic formula. Łukasiewicz was blown away by this, calling it a masterpiece of the art of deduction.
It's fascinating how they kept pushing the boundaries of what was possible within these logical systems. Okay, so now let's dive into the area that Łukasiewicz is most famous for, many-valued logic. How did this revolutionary idea come about?
It all started with his philosophical thinking about modality, especially the concept of possibility. Now, this might seem like a strange starting point since today we're used to modal logic being built on top of classical two-valued logic. But bear with me. He started with the usual modal operators necessity, LP, and possibility, MP, and their standard definition.
I'm with you so far.
Okay, good. Now, there are certain implications that seem quite intuitive, like if P is necessary, then P is true, and if P is true, then P is possible. Pretty straightforward, right?
Yeah, those make sense.
But then he asked, what if you also accept the converse implications? If P is true, then P is necessary, and if P is possible, then P is true. This is a very deterministic view. If you accept all these implications, possibility and necessity basically collapse into simple truth. There's no difference. And then he added the seemingly reasonable idea that possibility is two-sided. If something is possible, then its negation is also possible.
Okay, that makes sense. If something could happen, it's also possible that it won't happen.
Exactly. The problem is, if you combine all of this within classical two-valued logic, you end up with a paradox. Any proposition becomes equivalent to its own negation.
Whoa, that's not good. That's like saying something is both true and false at the same time. So how did a third truth value fix this?
Łukasiewicz's ingenious solution was to keep those initial intuitions about modality, but to find a situation where a proposition and its negation could be equivalent without everything falling apart. He imagined a proposition that wasn't definitely true or definitely false, but genuinely possible. To represent this, he introduced a third truth value, which he called half, alongside true, 1, and false, 0. Now, when a proposition P has this truth value of half, it's possible, and so is its negation, NP. If NP were true, 1, then P would have to be false, 0, and vice versa. But with this third value, they can both be possible.
So it's like a middle ground.
Precisely. He then defined logical equivalence so that it's true, 1, when both propositions have the same truth value. So when P has the truth value of a half, each NP, P is equivalent to not P, also evaluates to 1 true. The paradox is gone.
The third truth value saves the day.
Exactly. For a philosopher who's struggling with the complexities of modality, this is a pretty radical alternative to the traditional ways of thinking about it.
Absolutely. And he published these ideas pretty quickly, didn't he?
Yeah. His first paper on this, on the concept of possibility, came out in 1920. It was based on a lecture he'd given. And just 2 weeks later, he gave another talk explicitly titled On Three-Valued Logic. This time, he explained the basic principles for implication and equivalence with his new third truth value. These principles basically defined the truth tables for these connectives in what we now call outro, his three-valued logic. He also gave definitions for negation, conjunction, and disjunction within this system.
So he really fleshed out this new logical framework, and he saw this as more than just a technical innovation, right?
Oh, yeah. Łukasiewicz was proud of this. He said three-valued logic was, above all, theoretically significant as the first attempt to create a non-Aristotelian logic. He saw its foundation in the idea of indeterminism, suggesting that how useful it would be depended on how well this indeterministic worldview matched our experience of the world.
Indeterminism, that seems to be a big motivator for him. How exactly did he connect this idea to the third truth value?
For him, many-valued logic and indeterminism were deeply connected. He saw classical two-valued logic, with its strict true-false divide, as a kind of logical straitjacket.
Limiting our thinking.
Exactly. He felt it undermined the very possibility of real freedom and contingency in the world. In 1918, he gave this farewell lecture. He was leaving academia to join the Polish government, and in it, he declared a spiritual war upon all coercion that restricts man's free creative activity. And he explicitly named Aristotelian, two-valued logic, as the embodiment of this coercion. Three-valued logic, with its idea of objective possibility as a separate option, was his weapon in this war. He thought that possible events represented by this third truth value could happen without being caused, leaving room for free will and creativity.
So the third value wasn't just a mathematical trick, it had deep philosophical roots.
Absolutely. And he kept coming back to this connection. In 1922, he gave his inaugural lecture as rector of the University of Warsaw, later published as On Determinism, and he addressed this issue directly. He said, if a prediction about a future event, like a specific human action, is already definitely true at the time of the prediction, then that event has to happen. There's no freedom there. He argued that the only way to logically protect free will was to assign the third truth value, possibility, to such predictions.
So future contingent events aren't set in stone. They're genuinely open possibilities.
That's the idea. Of course, this line of reasoning has been criticized. For example, determinists wouldn't necessarily agree that a true prediction about a future event means it has to happen. And some philosophers have explored three-valued logic for other reasons, without rejecting the idea that every proposition is either true or false, or embracing indeterminism in the way Łukasiewicz did.
It's always good to have those alternative perspectives. Okay, so he broke free from the two-valued system with his three-valued logic. Did he stop there? Or did he explore logics with even more truth values?
He didn't stop there. Once he opened the door to more than two truth values, there was no going back. By 1922, he had already sketched out how to define truth tables for the basic logical connectives in systems with finitely many truth values and systems with infinitely many truth values, all represented as numbers between 0 and 1. He even came up with general formulas for implication and negation in these systems.
Infinitely many truth values. That sounds a lot like fuzzy logic, which is being used these days in things like engineering and AI.
You're right. In a way, Łukasiewicz, by proposing these infinite valued logics, can be considered the grandfather of fuzzy logic. In 1930, he himself said that out of all these many-valued systems, only the three-valued and the infinite-valued ones were philosophically important. He reasoned that if you think of truth values beyond true and false as degrees of possibility, then you could either have just one level of possibility, possible, which gives you three values, or you could have a whole range of possibilities like probabilities, which gives you infinitely many values. He even preferred the infinite-valued system because he thought it had a deep connection to probability theory.
A continuum of possibilities linked to the mathematics of probability. That's a fascinating idea. What about the more formal side of these logics? Did he try to axiomatize them?
He did, and his students were really key to this work. In 1931, Moses Weisberg, one of his students, found a complete set of axioms for the three-valued system. He also proved something that Łukasiewicz had conjectured, finding an axiomatization for the infinite-valued system, where you have as many truth values as there are natural numbers. These systems, though, were built only on implication and negation, and that means they're not what logicians call functionally complete. There are some truth functions you just can't define using only those two connectives. But the notion of possibility itself could be defined within these systems. Later in 1936, another student, Jerzy Supecki, showed that you could make OOS functionally complete if you added a special unary functor that always took the truth value, no matter what the input was. And Adolf Lindenbaum, yet another student, proved something really cool about the relationship between different Łukasiewicz logics. He showed when this set of tautologies the always true statements of one system is contained within the set of tautologies of another.
So a lot of technical work was going on, exploring all the ins and outs of these new logics. Now, you mentioned earlier that Łukasiewicz later had second thoughts about his three-valued logic and modality. What happened there?
Yeah, so after being happy with his three-valued approach for a while, it seems like in the early 1950s, when he was deep into studying Aristotle's modal logic, he started having doubts. A big issue was that in OO, you could get theorems of the form lo, it is necessary that knows, such as LCPP, it is necessary that it P, then P. Many modal logics accept that if O is a theorem in regular logic, then lo is a theorem in the modal logic. But Łukasiewicz wasn't so sure about this.
So he's questioning a pretty basic principle of modal logic.
Exactly. He used examples, some inspired by Quine, to show why he was uncomfortable. For example, it's true that 9 is the number of planets, but it's not necessarily true even though 9 is necessarily equal to 9. He felt that accepting all logical necessities as modal theorems muddied the waters between accidental truths and essential truths.
So the fact that there are 9 planets is just an accident. It could have been different, but 9 being equal to 9 is an essential truth.
Precisely. And more broadly, he argued that necessary propositions shouldn't be automatically considered more important or more certain than regular factual propositions. All his many-valued logics up to that point had theorems of the form lie, so he felt he needed a new approach to modal logic altogether.
So he needed a system where those kinds of statements weren't necessarily theorems.
Right, and that's how he came up with his four-valued modal logic, which he called He presented it in a 1953 paper, A System of Modal Logic.
So he creates a whole new modal logic to address these philosophical worries about necessity. That's quite a move.
It is. He even laid out the specific conditions he thought a good modal logic should meet, including having axiomatic rejections alongside axiomatic assertions. He took Meredith's single axiom for classical propositional calculus with negation and a variable functor, and added his own axiomatic assertion about possibility, along with 2 axiomatic rejections. And he defined special rules for both assertion and rejection. The resulting system is actually an extension of classical two-valued logic. It includes all the tautologies of classical propositional logic.
That's different from his earlier many-valued logics, which were explicitly non-classical.
Right. And unlike typical modal logics that extend classical logic by adding modal operators, is defined by what's called a characteristic matrix. That means its truth values and the behavior of its logical connectives are completely spelled out in a finite truth table. He used the symbol A for possibility, replacing his earlier M, and he defined necessity in conjunction in this system. And he found another possibility operator, which, on its own, has the same truth table as A, but they interact differently within the system. He compared them to identical twins who look the same individually but behave differently in their relationships.
A pretty good analogy, actually. But I understand that error isn't really considered a successful modal logic, right?
That's the general consensus. Łukasiewicz knew it had some odd consequences, like the fact that all possible propositions are compossible if they can each be true. They can all be true together, or that if a proposition and its negation are both possible, then anything is possible. But he still defended the system. However, most logicians think it just doesn't work very well as a modal logic, even though some have tried to give it a philosophically plausible interpretation. A big reason for this is probably his insistence on extensionality, the idea that the truth value of a complex statement is determined solely by the truth values of its parts, even when dealing with modal operators. And that's what led him to many-valued logic in the first place.
It's interesting how his deep philosophical convictions shaped his logical work, even when they led him down some less fruitful paths.
Okay, let's talk about his contributions to the history of logic. He's considered a real pioneer in this area, right? He is. Besides his groundbreaking work in many-valued and propositional logic, he really transformed the study of the history of logic. He's seen as the founder of the modern approach to this history, which emphasizes analyzing past logical systems from the perspective of modern formal logic. That's even the subtitle of his book on Aristotle's syllogistic.
And his work on Stoic logic was especially groundbreaking, wasn't it?
Absolutely. He basically rediscovered and completely reevaluated ancient Stoic logic. Back then, historians of logic, like Prantl and Zeller, thought it was just a flawed version of Aristotelian logic, but Łukasiewicz saw that it was something else entirely, an early form of propositional logic, and a pretty sophisticated one at that. He figured out that the Stoic indemonstrables were actually basic inference rules in a propositional system, like modus ponens in modern logic. He first presented this idea in 1923, and in 1934 he wrote this very influential work called On the History of the Logic of Propositions, which gave a comprehensive overview of the field, from the Stoics through medieval logic up to Frege and the modern propositional calculus. He really helped people appreciate how much the Stoics, especially Chrysippus, had actually accomplished. And he was pretty critical of earlier historians who didn't have a solid grasp of modern logic. He famously said that the history of logic must be written anew by people who really understood contemporary mathematical logic.
A pretty strong statement. He's saying you can't really understand the history of logic without understanding where it ended up.
Exactly. And then there's his work on Aristotle, which also had a huge impact, even though it sparked a lot of debate.
Tell me more about that.
So in 1951, he published Aristotle's Syllogistic from the standpoint of modern formal logic. It was a landmark book that changed the way people understood Aristotle. The thing is, he'd been working on it for a long time, and some early drafts and presentations were lost, unfortunately. His interpretation was based on two main ideas. First, that you should think of Aristotle's syllogisms not as rules of inference, but as conditional propositions. So, if all A is B and all B is C, then all A is C. And second, that Aristotle's term logic had this hidden propositional logic underneath it, which he should have made explicit.
Interesting. So he's trying to read Aristotle through a modern lens, a propositional lens.
Exactly. But while these ideas were influential, they also caused a lot of discussion. Now, many scholars think that Aristotle's syllogisms are best understood as inference rules, and that Aristotle didn't need a separate propositional logic in the modern sense. It seems like Łukasiewicz might have been imposing his own understanding of logic, which was very much influenced by Frege, onto Aristotle.
So maybe projecting a bit of himself onto Aristotle. But his general approach to the history of logic was still valuable, right?
Oh, absolutely. He really believed that Aristotle's logic was important and precise enough to be analyzed with all the tools of modern logic. And even though scholars might disagree with some of his specific interpretations, his general approach has been very influential. He formalized Aristotle's categorical syllogistic using modern symbols and axioms, and he even pointed out forms that Aristotle either explicitly or implicitly rejected. He was a big fan of Aristotle's categorical syllogistic, calling it very precise, but he wasn't so impressed with Aristotle's modal syllogistic. He even tried to analyze it using his own four-valued logic.
So he's not afraid to apply modern logic to these historical figures, even if it means challenging the traditional views. Okay, let's shift gears a bit. We talked about his commitment to indeterminism, but what other philosophical ideas informed his thinking?
Well, one of his most important and long-lasting philosophical stances was his rejection of psychologism in logic. He was influenced here by Frege, Husserl, and Russell. This led him to make a very deliberate change in his terminology. He stopped using the Polish word sąd, which means judgment, and has psychological overtones, and he started using zdanie, which means sentence or proposition. And later, Polish logicians followed suit. After around 1920, he didn't write as much about broader philosophical issues, except for his unwavering belief in indeterminism. He wasn't a fan of the Vienna Circle and their logical positivism. He disagreed with their conventionalism about logic, their dismissal of metaphysics as meaningless, and their focus on language.
So he had his own philosophical path, distinct from the logical positivists.
Yes, he believed in a strong connection between logic and reality. And while he thought logic itself was metaphysically neutral, his rejection of two-valued logic was ultimately based on his belief in indeterminism. Interestingly, later in his career, in the 1930s, he shifted from a nominalist perspective to a kind of Platonism. He even described how working on even small logical problems felt like encountering a solid, real structure, which convinced him that he was discovering eternal, mind-independent truths, not just making up systems of symbols.
Wow, that's a powerful image. It sounds like he really had a sense of awe about logic.
He did. What about his views on the nature of logic itself? What did he think logic was fundamentally about?
That's a great question.
A core belief he held throughout his life, and one that was shared by many in the Warsaw School of Logic, was that logic is fundamentally extensional. That means he thought logic is primarily about truth values, true and false, and not about things like the meaning of words or the subjective aspects of judgment. For him, sentences basically denoted truth values, and logic was the science of those truth values and how they combine and relate. This assumption was really foundational for him, and it had big consequences for his development of many-valued logic and his attempts to build a good mobile logic.
Makes sense. And there's a mention of potential connections between his ideas and those of Alexius Meinong. Can you tell me about that?
There are definitely some intriguing parallels and possible influences there. Łukasiewicz even visited Meinong in Graz. Both of them seem to reject the idea of a super-truth that's beyond just true and false. And this idea is reflected in Łukasiewicz's 4.